Okay, so once you get a feel for chain rule, this all kind of follows on suit. So, for example, looking back now at your page 25 in the log tables, two more functions we need to be able to deal with in chain rule if we have to are e to the x and ln x. So it's going to be nice and easy to chain rule these, okay? When you have e to the power of something more complicated than just x, it will differentiate to e to whatever that is times the differential of whatever that is. And ln x, again, instead of x, if you've ln of something more complicated than just x, it will be 1 over whatever that is times the differential of whatever that is. Okay, so let's try some questions and examples based on these two functions. So taking y equals e to the 5x and differentiating it, we straight away see that we have something more complicated than just x. So write down your chain rule boxes and then we can follow it. So following your setup here, what we have in our box, of course, is 5x, more complicated than just x. So it's e to the 5x times, and then differentiating the 5x becomes 5. So we write that then as 5 times e to the 5x, and that's your answer. Okay, so let's say you have f of x equals e to the x squared plus 2x. So again, we have something more complicated than just an x. So put your chain rule boxes down and we'll follow it. So that is going to be e to the x squared plus 2x, because that's what goes in there, times the differential of x squared plus 2x. So differentiating x squared, we get 2x, and differentiating 2x, we get 2. So we'd write that as 2x plus 2 times e to the x squared plus 2x. Let's try y equals log of 3x squared in the base e. And of course, log in the base e is the same as ln. Okay, so that's the same as ln of 3x squared. So chain ruling ln of something more complicated than just an x, differentiates to 1 over whatever that is times the differential of whatever that is. So that becomes 1 over 3x squared times, differentiating now 3x squared, bring down the power, take 1 away, and we get 6x. So that gives you 6x on the top over 3x squared on the bottom. And of course we can tidy that up. 3 goes into 6 twice, and x will cancel out one of the x's on the bottom. So we're left with 2 over x. Okay, so let's take a look at this example. So first thing we're going to do here, because we've got the square root, is we're going to rewrite that as a power of a half. Now, from your laws of logs, when you have a log to a power, you can, of course, bring down the power. So we can rewrite that as that. Now, that's a really useful thing to use your laws of logs to help simplify what you're being asked to differentiate. So now I'm going to differentiate. And obviously, we're talking about ln of something more complicated than just an x. We don't have to worry about this half because it is just a number, and a constant multiplied won't affect the differential, it will just stay. So all I'm considering is the log in the base e, which is ln of course, of this. That will of course differentiate to 1 over whatever that is, which is that, times by the differential of that. So then when I go to differentiate this, I can see I'm going to have to apply quotient rule. All right, well, I'll do that in a minute. Okay, so let's differentiate. So dy dx is equal to, remember we have the half there. Then we have 1 over, and in that box we're putting 1 plus x over 1 plus x, times by then the differential. Okay, this is what I'm going to do over here. So a little aside, this differential box, let's work that out. So we're differentiating what is in this box. So in other words, x over 1 plus x is what we're differentiating. So u is equal to x, v is equal to 1 plus x, du dx is equal to 1, dv dx is also equal to 1 because 1 differentiates to 0 and x differentiates to 1. So then we have v du dx minus u dv dx all over v squared. All right, multiplying that out, then I end up with 1 plus x minus x all over 1 plus x all to be squared. And they cancel out, so I'm left with 1 on the top only and 1 plus x all to be squared on the bottom. Okay, so that is my differential. So that's what I'm subbing in for there. So in here it goes 1 over 1 plus x all to be squared. Okay, now we need to do a little tidy up on this. Keep your half. Now when you have 1 divide by a fraction, remember you're dividing fractions. I'll consider 1 like 1 over 1. Dividing a fraction, you will flip the second fraction and change it to times. Okay, so that's like that. And timesing by, of course, this. So that leaves me with, on the top, 1 times 1 plus x times 1 is, of course, 1 plus x. On the bottom, 2 times x times this. Obviously, times the 1 is just going to be 2x, 1 plus x, all to be squared on the bottom. And, of course, this will divide into one of these on the bottom to give 1 on the top, 2x, 1 plus x. And that is the final answer.